Before we start section 4.5, I figured I'd give a multiple choice challenge. If this was live in class, I'd make it worth a bonus point, but I don't want to watch my timer run down for 2 minutes on a video, and neither do you, to be quite honest, so I'll just let you try this out yourself. You can pause the video, see if you can come up with an answer that you think is right. I have to be honest with you guys, most of the students miss this first time through. The overwhelming majority miss it, so if you can get this right on your own without cheating and looking ahead, you are one of the very few. Okay, that was the fastest 2 minutes of my life. Let's try this out. Obviously, this person who made this problem up is doing a U sub. That person would be me, actually. It's okay. So this is the U right here. Let me just write this down. So U is 3x squared minus 11. Maybe you guys just got done doing this. So your du would need to be 6x dx. I'll kick the 4 out. I like to play it safe. I'm going to give myself a 6. I'll divide by 6. So I've got the 4/6 up front. I like B and D with the 2/3. But who knows what it's going to end up being. Those might not be right. Okay, 6x dx becomes du. We write that over here. So we've got du accounted for. And then we have u to the 4th. There's a 4/6, which is a 2/3 in front. You like how I made the reciprocal mistake on C? C is wrong. Okay, and then let's see, limits of integration are 2 and 3. So that would be choice B, which is the wrong answer. I bet you people picked that too. That's the one everybody picks. You know, that shows some knowledge, but you got tricked. And the reason that that's not right, the reason that you got fooled, like everybody else gets fooled, and the reason that we're learning this section is so you don't get fooled. Do you notice that the choices that I left you guys with were still in terms of u's and du's? I didn't go back to x anymore. That's usually what we do. We go like, oh, a u's not part of the problem. Let's change it back to x's. Then we plug the numbers in. The 2 and the 3 are x limits. We need u limits. So what I have to do is I have to take the 3, which is an x, and plug it in. Okay, let's see. 3 squared, that's 9. Times another 3, that's 27 minus 11. 27 minus 11 is 16. Oh my gosh. And if you try the 2, same deal. 2 squared, that's going to be 4 times 3. 12 minus 11 is 1. That's your correct answer, choice D. Hardly anybody picks it. Some people forget that, you don't go up by a power, divide by the new power, and still leave the integral sign there. In all 6 choices, nobody's integrated anything yet. So if you pick something with a, u to the 5th on there, you also got tricked. So D is the answer. All right, let's talk about the lesson itself. Okay, I'm going to do this number 1 the way we've always done it, via u subbing it. I'll pick x to the 5th plus 2 for my u. Du, of course, will be 5x to the 4th dx. I think I can wing it here. I'll cut this in half to make it 5x to the 4th dx. To make up for it, I'll throw a 2 out front. So it's going to be 2 integral u to the 3rd du. And of course, that's going to have to be integrated. And there's a couple things we can do. Let's go up by a power, divide by the new power. Do you notice in the last couple sections when I did problems like this, I purposely did not put the limits of integration here and here. I've been leaving them off. That was very intentional when I switched letters. I don't know if you picked up on that. I didn't mention it to you on purpose. I didn't want to teach this lesson too early. All right, let's see what we have. U to the 3rd being integrated will be 1/4 u to the 4th. All right, so that's going to be 1/2 u to the 4th. Let's put the u back in. X to the 5th plus 2. And then again, now that we're back to x's, now I can put the 1 and the 0 in. Let's go from 0 to 1. I'll leave the 1/2 out like I usually do. When you dump the 1 in, you get 1 plus 2. That's 3 to the 4th. 3 to the 4th happens to be 81. Minus, put the 0 in. Don't blow it off because it's going to be 2. 2 to the 4th is 16. And so your final answer is going to come out to be 1/2 of 65, which is 32.5. All right. 32.5. Now keep that answer in mind because I'm going to do the same exact problem again, just with a slightly different twist. The only difference here is a very light blue background, but otherwise it's the same problem. So the answer better come out to 32.5 again. Let me just write that down here so I remember what it was. I'm going to take a slightly different approach here. It's just very subtle. I'm going to start out the same way with U sub. Nothing at all has changed. Still the same as last time. But now, instead of changing everything back to x's like I'm going to do, let's go ahead and change the limits of integration now. Let's take the 1 and the 0 and plug them in. If you start with the 1, you put it in, 1 to the 5th is still 1, plus 2, that'll be 3. Plugging the 0 into the same place will be 0 plus 2. All right, now let's proceed. So everything comes out the exact same way it did before, except you don't have to plug the x's back in. You don't have to plug in this x to the 5th plus 2. You're already in u's, you've got your u limits. Now put the 3 in. 3 to the 4th, of course, is 81. A little deja vu here. 2 to the 4th is 16. The 1/2 is still in front. It's still going to come out the same answer. So it really doesn't matter which way you do it. A lot of people look at this second way and they're like, I don't like that. I'd rather just change it back to x. I'm comfortable with that. That's fine. Nobody's going to make you do it this way. I just wanted you to know about this, primarily so you don't screw up the multiple choice like most people I'm sure probably did before I started the lesson. That's really the main reason that we teach this. In fact, let's give you a shot at redemption. Let's do one more multiple choice and see if you can get it right this time. If you didn't, of course, that is. Okay, again, normally 2 minutes, but I'm just going to let you try it now. Go ahead and pause me. And then about 10 seconds from now, I'll start talking it through. Okay, go. Okay, let's see what happened. I decided to make u tangent of 5x. That turns this part into u to the 5th. And then, of course, du, the derivative of tangent, of course, is secant squared. And there's a chain rule. So I need a 5 secant squared 5x dx. As long as I do a 5 and a 1/5, I will have what I need right here. So that becomes the du. I still have not integrated anything yet, and there's still a 1/5 in front. Since I'm not going to integrate, anything with a 6th power in it is wrong, so hopefully you didn't pick C or E. All right, let's see what happens. And obviously, because we're going to be plugging the pi over 4 and pi over 5, which are x limits, into the u over here, I have a feeling anything that still has the pi over 4 and pi over 5 on it, like choice A, are going to be wrong. I'd be amazed if tangent of 5 pi over 4 is actually pi over 4, and it's not. The tangent of 5 pi over 4, let's try that out. Well, 5 pi over 4, let's see, pi over 4, 2 pi over 4, 3, 4, 5 pi over 4, that's in quadrant 3. That's positive down there. Tangent's positive in quadrant 3. And the tangent of pi over 4, that reference angle is 45 degrees. That's 1. So we want something with a 1 on the top, which B and D both have, so that's a good sign. So it all comes down to the lower limit. Let's try the pi over 5 in. That would become the tangent of pi, and pi is 180. The tangent of 180 is just simply 0. So again, that's why we talk about changing variables. It's not so that you have two different methods to have to memorize. It's just so you have options and flexibility when doing some of these problems. So if you're doing the regular problems like the last one we did and you don't want to go against something you're comfortable with, I'm fine with that. That's not a big deal to me. This problem is a little different. We're changing gears a bit. It says integrate using a substitution of variables. I'll start off with a u sub. And my gut feeling is use the thing that has the square root on it. And that is correct. So u is x minus 4. But then du is just 1 dx. And I'm thinking du is dx? That doesn't seem very effective. I'm just switching letters. I'm not getting rid of my difficulties in life here. And I feel like I've kind of run out of steam. Maybe I picked the wrong u, but if I pick the top and I pick 6x plus 5, du will just be 6 dx. What do I do with that square root down there? It's just going to sit there and stare at me, taunting me. So that's not going to work either. The key here is you need a third step. You need to use a little bit of algebra 1 on the first step and solve for x. If u is if u is x minus 4, then x, if you add 4 to both sides, would be u plus 4. And now we're in business. I'm going to change all the x's to u plus 4s, and we'll see what we have. Okay, now with the substitution, and you can see some really nice things happening. The denominator is great. These parentheses I put down there aren't really serving a purpose. I'm not sure why I did it, but 4 minus 4 is 0. And so that'll just be a radical u down there. And the numerator will be 6u plus 24, there's another 5, so plus 29. Okay, now I can rewrite this problem. This is actually u to the negative half power. So if I brought it up top and distributed it, I would have this. Just a quick second, I realized that even though du and dx are equal, I've been writing dx. These should all be du's here. At least I got right over here, third time's a charm. All right, so that's going to be 6u to the positive half plus 29u to the negative 1 half. du. All right, now I'm ready to integrate. Now I can do it. Up by a power, that's going to be u to the 3 halves. Times 2/3. 2/3 of 6, that's 4. This is going to go up by a power as well. That'll be u to the positive 1 half. Divide by a half, that's times 2. 29 times 2 is 58. All right, so I have that so far, plus c. U is not anything that was in the original problem, so I have to take the u's out and put in x minus 4's in their place. I'm also running out of room, so let's clear out some space. All right, so that is my answer. Now, I've got a little bit of bad news. That might be the answer, but again, since we are taking a test at the end of the year that's half multiple choice, you might find that they're going to start to make the answer look a little different. You could factor out a 2 because 4 and 58 are, in fact, both even. But worse yet, you could factor out x minus 4 to the half. And there's a good chance they might do that to you to test your algebra. That's why we did that worksheet in the beginning of the AB class or at the end of honors pre-calc. All right, let's see what's left from this. I had a 4 divided by 2, so there's still a 2 there. But it's going to be x minus 4 to the first power. Again, if you're not sure, you can always check yourself by distributing with the 1 there. That does make 3 halves when you add. The 58 is now going to be back to a 29, but this has been factored out. Again, you can check. There's still a plus c on it, of course. This entire bracket is nothing more than 2x minus 8 plus 29. That's actually 2x plus 21. So you might see the answer written like this. And my fear is that maybe you got this answer here and you don't realize it's the same thing as this answer here. What if in the multiple choice setting they have none of the above and this is their choice, let's say B, and you don't recognize it? So it's a good idea to be able to still practice your algebra somewhat. Okay, here we go, number 3. Again, using the substitution of variables, this is going to require, like the last problem, a 3-step U sub. It would be normal to make u 2x plus 5. That's a great move. Your du then, of course, would be 2 dx. We'll have to put a 2 on the dx, 1/2 out front, business as usual. That becomes the du. This part right here is looking good. It's u to the half. 1/2's out front. But then the x squared is just staring us in the face like, what are you going to do about me? And I'm like, I don't know. So I have to solve for x. So if you take your top equation right here, you subtract 5, divide by 2. X is going to be u minus 5 divided by 2. And so I will have to plug that in. I'm going to be squaring that, so I think I'm just going to square it on the fly. Let's do this. 2 times 2, of course, is 4. And u minus 5 times u minus 5 is u minus 5 squared. All right, so I have that. I don't like that 4 being where it is. I can recognize that it's a 1/4, actually, and I can kick it out to be with the 1/2. That'll make 1/8. I also don't like the way the inside looks. By the way, the inside of an integral has a name. It's called the integrand. I don't know if I've mentioned that before, but in case I haven't, I'm going to put the u to the 1/2 first. Now, I would love to use distributive property, but I can't. Distributive property only works when this is first power and it's squared, but I can square it out in my head. It's going to be u squared minus 10u plus 25. And now the parentheses is to the first power, so I am able to distribute. So I will. And that's going to come up here, 1/8. I've got u to the 2.5 power, also known as 5/2, minus 10 u to the 3/2, plus 25 u to the 1/2. And of course that's du. And now I can integrate it. And so I will. I feel like I'm going to need more room, so copy what you need or pause the video. I'm going to erase some things. Okay, let's integrate. 1/8 just being out front. Inside, I'm going to have 2/7 u to the 7/2. Hopefully this isn't too fast. If it's not, you can always pause me. Minus, we got 10 over 1. Integrating u to the 3/2 will be 2/5 u to the 5/2. Plus, here's the 25 over 1. And u to the 1/2 would become 2/3 u to the 3/2. Plus c. We can simplify a little bit here in the middle. That's just going to become a 4. Let's clean this up a little bit and just put the 4 in there. I'm also going to clean up this last fraction and make it 50/3. There we go, that's better. Now most textbooks, to get rid of the parentheses, will probably distribute this 1/8 through. So I'm going to do just that. 1/8 times 2/7 would be 1/28. It's u to the 7/2. 1/8 times 4 is 4/8. That's going to be minus 1/2 u to the 5/2. And 1/8 times 50/3 is going to simplify down to 25/12 because you can cut this in half. And think you can see the 25/12. And that'll be u to the 3/2 plus c. Just instead of u, put the 2x plus 5 back in each time. And there's the answer. Now again, I realize you could factor out a 2x plus 5 to the 3/2. That's way over the top. They will not have you do that. You're not going to have a trinomial. Things will be squared. That would be a disaster. They might try it on something like the previous problem, number 2, but on this, that's fine. Remember, if it's on an FRQ, you don't have to simplify anyway. All right, last problem. Substitution of variables one more time. The only difference here is it's a definite integral. We have limits of integration of 0 and 4. So we'll do it the way we normally do, and then we'll plug them in. All right, let's try to use some. The ugliest part of the problem is the radicand inside the square root. So 2x plus 1 becomes the u. Du becomes 2 dx. All right, so we've got our du. We've got a u to the negative half. But again, we've got that x up top. Let's see what x is. I'll tell you what x is. It's u minus 1 divided by 2. And so this x up top is going to change to u minus 1 divided by 2. I'm just going to pull the 2 out front. It's not really a 2, mind you. It is a 1/2 because of its denominator location. So we're going to have a 1/4 out there. And I'm going to rewrite this. Instead of radical u on the bottom, I'm going to call it u to the negative half. I'm going to distribute it through. Again, I have not integrated anything yet, so don't jump the gun here. It's going to be u to the half minus u to the negative half du. All right, let's integrate. Up by a power, divide by the new power. 1/4 can stay in front. U to the 1/2 will become 2/3 u to the 3/2. This next thing will be u to the 1/2 when it comes up by a power. We want to divide by a half, which is times 2. It'll still be negative or minus in front. You can always check if you want by doing derivatives. And you know what, since we're in the new unit, I'm going to leave the u's in just for something different. I'm going to change the limits of integration instead of 4 and 0. We'll see what they become. Let's plug them in. They are x limits, so they go in here. The 4 is going to turn into 8 plus 1, which is 9. The 0 is going to turn into 0 plus 1. I love the fact that your teacher both made those perfect squares. Man, I like students. I could have made that a lot worse. 9 to the 3/2. 9 to the 3/2. That's 3 to the 3rd. That's 27. 2/3 of 27 gives me 18. 9 to the 1/2 is 3. 3 times 2 is 6. Okay, so the first part will be a 12. Minus, because that's first fundamental theorem. In goes the 1. 1 to any power is 1, so this is just going to be 2/3 minus 2. 12 minus negative 4/3. Yeah. Let's make common denominators while we're here. 12 is actually 36/3. So we're going to have 1/4 times plus plus 40/3. Some reducing can occur. And the answer is 10/3 or 3 1/3. And that's it for section 4-5. So again, in summary, you can take a a U sub, and if it's not working, you can throw a third step on it. And sometimes the problem will work out pretty well. You can also change the limits of integration from X values to U values if you don't want to plug things back in again and change the problem back to X's. Some people like that better, some people don't. You have the freedom to do it either way.